let's look at this first example of linear programming. There's this guy, we'll call him Mike. Okay, so Mike works in factory. Okay, so he's been hired in this factory. Now, what happens in this factory is that they make shirts and they make skirts. So this is basically a skirt and shirt factory. Now, when he was hired, his employer just told him maximize profits. So I don't care what you do, all you have to do is make sure that the profits are maximum. Okay, so Mike, being a smart guy, he noticed that in order for him to make a profit, he has to consider the limitations. What limitations are there in making a profit? So he noted that there is only 1,500 meters of material available. There are 1,400 hours available for cutting because you need to cut skirts in order to make them. You need to cut shirts in order to make them. And you can only afford to pay 1,400 worth of hours for the people that do the cutting. Okay, and for the trimming, he only has 1,600 hours available. So he pays the people however much he pays them, but he can only afford to pay them a maximum of 1,600 hours to do the trimming. Now, there's some information that he got from the previous guy who was doing the job about the manufacturing process, and this is what we have over here. He noticed that when he makes one skirt, there's a profit of $25. When he makes a shirt, there's a profit of $20. He needs 3 meters for a skirt and 2 meters in order to make a shirt. Now, in order to cut a skirt, it will take the person who does the cutting an hour, and for a shirt, you need 2 hours to do that. Okay, then there's the trimming because it's a two-step process. You need to cut, then you do the trimming and whatever else that involves. So for a skirt, you'd need 2 hours and 1 hour for a shirt. Now, this is typically the type of problems that we will face or deal with linear programming. So you have a situation with Mike in a factory, in a farm, or wherever else, and then you are asked to do something, either maximize the profit, minimize the costs, or something in that line. So now the big question is, how many skirts and shirts should you make in order to maximize the profit? Because ideally, somebody would think, why don't you just make as many skirts and as many shirts as possible? That would be ideal because if you just make 1,000,000 or an infinite number of skirts and shirts, then your profits would just go up. But we have limitations, and we always have to include these limitations incorporated with this information that we're given to see what is the best number of shirts and skirts to make so that our profit is the maximum that it can be. So this, all you need to do is follow some steps. You follow the steps, you will always arrive at the answer. Now, step number 1, you need to select and allocate the required variables. So we do this by saying let X be the number of shirts and let Y be the number of skirts. These X and Y don't actually matter unless it's specified in the question. You can put P and T, you can put S and K, you can put L and Z. It doesn't actually matter. So this is just so that it has a mathematical way. And in math, we like X and Y, so why not use X and Y? Okay, so what Mike did is he summarized all these limitations and all this information in a table as seen below. So you can see here I have a column of shirts and a column of skirts, and here it says available. So if we look at the second row, it has the profit because one shirt makes a profit of $20, one skirt makes a profit of 25. And note that over here I have X in brackets because X represents the number of shirts, Y represents the number of skirts. And here under available in the profit, we don't have an amount of profit available. We just want to maximize it. That is our aim. We want our profit to be as maximum or as maximal. want it to be maximum. That's what I mean. Okay, then the material, one shirt takes 2 meters, a skirt takes 3 meters. How much is available? 1500 meters. That means no matter how many shirts and skirts we make, the total amount of material we have cannot exceed, or the total amount of material that we use cannot exceed 1500. Same thing for the cutting hours. It takes 2 hours to cut a shirt, it takes 1 hour to cut a skirt, but the total number of working hours for cutting cannot exceed 1400. That is because we have to pay these people who do the cutting, and we don't want to just pay them an infinite amount of money because we want our profit to be high. And the same thing is true for trimming. We have an hour for shirts, 2 hours for a skirt, and the total amount that we have available for trimming is 1600 hours. Okay, again, this is because these are people that we pay to do the cutting and the trimming. The working hours that people can have, you cannot just make somebody work indefinitely, and even if you did, you couldn't afford to pay them that much. Okay, so step number 2, we need to formulate the objective statement in terms of variables. Now we need to bear in mind what we are doing. Are we minimizing or are we maximizing? Okay, now the objective is what is our aim. Now remember what the boss said. The boss said profit, 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 profit. Okay, so that is our objective. And what do we want to do with the profit? We want to maximize it. And the total profit that we will make will depend on the profit from the skirts and the profit from the shirts. And that is why we have this. So we want to maximize. See, I have summarized everything I have in this sentence as I want to maximize. What do I want to maximize? The profit. And what is the profit equal to? The total profit will be the 20 from the number of shirts and 25 from the number of skirts. And that all together gives us the total profit. So that is step number 2, formulate your objective statement. Step number 3, you need to formulate the constraints in terms of the variables. Now your constraints are also your limiting factors. Now these you will write as inequalities. Now the first one, what limits us is the amount of material that is available. Okay, and the number of shirts we make and the number of skirts we make multiplied by how much each takes should be less than 1500. Okay, so 2 meters here, 3 meters there, multiplied by how many of each you make altogether should be less than 1500. Then what else limits us? The cutting time. Now it takes 2 hours to cut X, it takes 1 hour to cut Y, and altogether when we add up the cutting time, there should be less than 1400. Then the trimming time, it takes 1 hour for the shirts, 2 hours for the skirts, and when we add all that trimming time, this should all be less than 1600. Okay, then another thing that you shouldn't forget, this is quite important, is that X, that is the number of shirts, should be greater than or equal to 0, because you cannot make less than 0 shirts. 0 is the minimum number of shirts you can make. And the same thing is true with the skirts. You cannot make less than 0. There must be 0 or more. That means you're saying I'm only going to make shirts, and then I will no longer have a skirt and shirt factory. I'll only have a shirt factory, and that's how I get my maximum profit. That is fine, but you cannot make less than 0. Okay, so what we need to do now is just plot these inequalities. So how you do it is you first draw a line and then you will shade the unwanted region out. Now the unwanted region is simply the part above the line or below the line, depending on what the inequality is. So in order to draw a line, you just need 2 points that lie on the line, and I'm sure you did this last semester. You know how to draw a line. You need to take 2 points on the line and then you connect them. So we start with the first constraint. You have 2x plus 3y is less than or equal to 1500. You see that one? Okay, so there it is. 2x plus 3y is less than or equal to 1500. Now what we are going to plot is actually this line here. Instead of an less than or equal to, we will have an equal to. Now to find any 2 points on a line, you simply need you can substitute x and y for anything. It doesn't actually matter. But the easiest to do is to plot the intercepts. So you have your x-intercept. Now at your x-intercept, we know that y is equal to 0. So what you do is you'll substitute y is equal to 0 over there and then solve for x. So we do that. We have 2x plus 3 times 0 is equals to 1500. Anything times 0 is just 0. So I have 2x is equal to 1500. And then I want x, so I divide by 2 on both sides. Divide by 2. Divide by 2, I get x is equals to this 750. So that means this point here, 750, 0 is a point on the line. That is the first intercept. Then I do the same thing with the y-intercept. I have x is equal to 0. Okay, then I will substitute 0 there and then solve for y. So I have 2 times 0 plus 3y. This is equal to 1500. Anything times 0 is just 0. So I have 3y. This is equal to 1500. I want y, so I divide by 3 on both sides. Divide by 3, divide by 3. So I have y is equal to 500. Okay, so that is the y-intercept, and at the y-intercept itself is 0, 500. Okay, so now that I have these 2 points, all I need to do is plot them on my graph. Right, so there's my graph, and I know the 2 points on there. I hope you can see these numbers. Let me try and zoom in just a little bit. Okay. Let's use the camera. Okay, so if it's too small, I'll keep reading what I have, then you will know what the values are. So over here in the bottom, I'm counting in hundreds. So this is 100, 200, 300, and so on. And on the y-axis, I'm counting in 200. So it's 2, 4, 6, 8, 1000, 1200, 1400, and so on. Okay, so our first line that we need to plot is 2x plus 3y is equals to 1500. So I need to pick the 2 points. Remember the first point was 750, 0. So I go on the x-axis. 750 is here, 0. So this is my point because this is 700. Sorry, 700 is over there. I'm getting confused. So this is 700. That is 800. So the point I plot is exactly halfway. There it is. And then the next point also on the line is 0, 500. So 0 on the x-axis, 500 on the y-axis. That is this point over here. So what I do is I take my ruler, connect the 2 points. Okay, make sure your ruler doesn't move. And there we go. So I've drawn that line. I hope you can see it. And then I'm going to label it. This is 2x plus 3y is equals to 1500. Okay, so very simple to do. Now, when want to shade out the unwanted region. So remember, I shade out the part that I do not want. What I want is that 2x plus 3y should be less than 1500. Less than means below the line. What I do not want is above the line. So I'm going to shade everything that is above the line. And this is simply how I do it. Shade, 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 shade. Like that. Okay, so that is how I draw the line and then include the less than or equal to. Now if I were to test if what I have is correct, I would pick any point here in the unshaded region. Let's say I pick the origin. The origin is 0, 0. Now remember the inequality, it was 2x plus 3y should be less than or equal to 1500. Now this point here, it'll be 2 times 0 plus 3 times 0, which is 0. 0 is less than 1500. So this point satisfies the inequality, therefore it is in the right region. Unlike if I picked this point over here, it is 0, 1000. And remember, it was 2x plus 3y should be less than 1500. So it's 2 times 0, which is 0, plus 3 times 1000. 3 times 1000 is 3000. Is 3000 less than 1500? No, it is not. So that is not in the region that I want. So that's just a way for you to check if what you have is correct. Okay, next is 2x plus y is equal to 1400. This is the line I want to draw, so I need to work out what are the x and the y-intercept. Remember, with the x-intercept, y is 0, y-intercept, x is equal to 0. So I will try and do all of these lines in one step and then we plot them in a bit. Okay, so here, when x is equal to 0, what do we have? If this is 0, then I have y is equal to 1400. So y is equals to 1400. So that means this is a point 0, 1400. And then here, if y is equal to 0, so that means y is equal to 0. That means 2x is equals to 1400. And that means x is equal to 700. Okay, so feel free to pause the video to do the calculations. I'm going a little bit fast, but this is simple algebra, which I'm sure you know how to do. Okay? Okay, so this is the second line that we will draw in just a bit, and this point here is 700, 0. Okay, the third one is x plus 2y is equal to 1600. Okay, so again, we look for the x and the y-intercept. So we say that x is equal to 0. So when x is equal to 0 here, I have 2 times y is equals to 1600, and that means y is equal to 800, and that means this point here is 0, 800. And then when y is equal to 0, so if this is 0, then that means x is equal to 1600. So x is equal to 1600, and then we have the point 1600, 0. So I'm only working out 2 points per line because that is all that I need. You could work out 3 or more, but you will notice that they all fall in the same line, so there's no need to draw them. Then we have this one here, restraints. X is greater than or equal to 0, so it translates to x is equal to 0, which is just the y-axis. So this one is the y-axis. X is equal to 0. This is just the y-axis, which is drawn for us already. And from there, we have y is equal to 0. This is just the x-axis. Okay, so we don't need to redraw it because it'll be there, but we do need to shade off the parts that are not wanted. Okay, so now that we have all the points that make up all the lines, all we need to do is go to our graph and then draw them and then shade off the unwanted regions. Okay, so let's plot the next one. The next line we plot is 2x plus y is equal to 1400. And if you remember, the 2 points that lie on that line are 0, 1400, and then 700, 0. So we start with 0, 1400. That's over here. I plot the point, and then 700, 0. So 700, and the 0 is over there. I hope that's right. Yes, it is. Okay, then again, you take a ruler and connect the 2 points. I have that one there, and I have this one here. So take my ruler, connect the points. Okay, there we go. Okay, now you need to remember the inequality. The inequality said 2x plus y should be less than 1400. Now, as a rule of thumb, less than means below the line is what you want. So everything above the line, you shade it. So above the line, I'm just going to shade it. This part. And this part is shaded because it is above this one here. So this part here is shaded. It is shaded because it is above this line, and that's not what we want. Okay? So as long as it is above the line, that's not what we want. So if I were to look at this and make it huge, or I would zoom in, the only part that is not shaded is this part here going down. This is shaded because it's above that line, and that is shaded because it is above that line. Okay, so those are the 2 lines. Always label your lines. So this is the line 2x plus y is equal to 1400. I hope you can see this. You label your lines. Okay, and then the next line is x plus 2y is equal to 16. Okay, the next line we have to draw is 2x plus 2y is equal to 1600. Now I just realized from our intercepts the second point, or the x-intercept, does not lie on my graph because of the scale that I've chosen. So what you do is you can pick any other point. Let's say you make x is equal to 1600 is equal to what is it? X is equal to 600, and then you solve for y, and then that will be your point. So I'll use the first y-intercept. At the y-intercept, we have y is equal to 800. And my second point, I made x is equal to 600. And when I solve that, I get y is equal to 500. So the point 600, 500, where is that? This is 6, so this is 500. I need to use my ruler just so that I don't make any mistakes. So 500 is just there, and it has to be above 600. So there it is. Okay, so this is the point 600, 500, which lies on the line x plus 2y. And I only did that, or I didn't use the intercept, because I noticed my scale isn't big enough, or my paper isn't big enough for the scale that I want. Then what I do is I take my points and I connect them like that. Okay, and then I will continue. Now this line over here is unique because it lies entirely in the shaded region, or the part that we're going to consider is in the shaded region, but it's always good practice. Just shade off the unwanted part. We say that x plus 2y should be less than 1600. So less than is what we want, and everything above we don't want. So we can see what I'm shading is already shaded because of the other lines, or mostly. Yeah, it is completely. This line continues because it is above the other 2 lines that I've drawn already. And then we can label it. This is x plus 2y is equal to 1600. So again, the only part that is not shaded is this part here. Then there's a corner here, and then that is not shaded. Everything else is shaded. And then the last two, we have x is equal to 0. We said x is equal to 0 is the y-axis. So I would draw this line. But there's no need for me to draw it twice, but just as a demonstration, this is the line I would draw. Then I want x to be greater than 0. Now greater than, if we're looking at a vertical line, is just on the right. So we want, this is our line, now we want the part this side. So everything on this side we do not want. Okay, then we look at the last line, y is equal to 0. Y is equal to 0 is the x-axis. So it's already drawn, so I don't need to, but I would draw a line like that. And then my inequality is that y is greater than or equal to 0. Greater than, again, remember, if it's a slanted or a horizontal line, that is above. So everything below we do not want. So this is shaded. Okay, so that is just how to draw the lines, which I'm sure you're already familiar with, and then how to shade off the unwanted region. Now something you should note is that our profit, in terms of the number of skirts and shirts you should make, will always be at these corners. So it'll be either here, it'll be there, it'll be here, or it will be there. Now, for now, we can just read out these points. This is the origin, so it's 0, 0. Then this point over here, this is 0, 500. That is 500, 0, 500. Now this point over here, this is, because we're counting from there to there, is 100. So 100 divided by 4 is 25. So this is 675. I need to get my scale right. This is 625 and 50. Okay, so that is that point there. And then this one over here, this is 700, 0. So those are that is where your maximum profit is going to come from. So one of these. Now this is obviously not the answer, because if I make no skirts and no shirts, I'm not going to make my maximum profit. Now we could check this one. Maybe I make 0 shirts, because X is shirts, and then I make 500 skirts, and then I see how much profit will I make. And then here I could make 650 shirts and 50 skirts, see how much profit I make. And then I have 700 shirts and then no skirts, and then I will compare them. Now in just a bit we will see how to work out which of these is the actual answer. Now you could substitute them into the formula for the profit, and then that will also tell you, but there's another method or something additional we have to do, and we will still get the same answer. Okay, so the last thing we need to do is draw this objective function line. If you remember this is the formula we had for the profit. We say the profit is 20 times the number of shirts we have plus 25 times the number of skirts that we'll make. That will give us the profit. Now this we need to also plot on our graph, but what you need to notice is this is a little bit different from the others. Firstly, I have an equal to sign over here. With the others, I had less than or greater than. So that one was an inequality, and then I would draw a line, and then I would shade off the unwanted regions. But this one, it is an equal to sign. And the next thing you'll notice is that here, instead of a specific number, I have P. Okay, so I don't have 25 or 300 or something like that. I have P, so that is different about it. But you would still need to draw this objective function line, and what you do is you pick a value of P. The value of P that you pick does not actually matter. It doesn't matter whether you pick P as 1 or 5 or whatever you decide to make P. Your answer will be exactly the same, because with this P, in this line that we draw, this is not a unique line. Unlike the other lines that we drew before, those were unique, specific lines. But this P is a specific line, and what we want is just a family of parallel lines. You just need to show me one of them, and then we will see what other parallel lines to it look like. Okay, so how should you pick your P? Pick a P that is a product or is a multiple of these numbers over here. So it's 20 and 25. Okay, and the way you should pick them is your line that you make should fit nicely in the graph that you have drawn. Okay, if I have, for example, if I were to say this is equal to 1, I try and work out, let's say I say P is equal to 1, for example. So I'll have 20x plus 25y is equal to 1. Then I can find the x-intercept. So when x is 0, then this means that y is equal to 1 over 25. And then the other point here, when y is 0, this means that x is 1 over 20. That is an objective function line, and there's nothing wrong with that. The only problem is if I look at these points here, 0 and 1 over 25, plotting them on the graph that I have drawn will be extremely difficult. Okay, because my graph, I'm counting in 50s. Now, if I'm counting in 50s, it is going to be very hard for me to draw something accurate where I have 1 over 25, because I have to do a lot of guesswork. So I will not be able to plot these ones. So what you should rather do is pick a reasonable P. Okay, so here I am going to pick P equal to 5,000. So I have 20x plus 25y is equal to 5,000. Now, why did I pick 5,000? 5,000, I picked it because 20 divides 5,000 and 25 divides 5,000. Because if I make this one 0, I have to divide by 25 on both sides. So on this side, I will get a whole number, which is what I want. And if I make this one 0, I have to divide by 20 on both sides. And when I divide 5,000 by 20, I don't get decimals. So I'm trying to avoid decimals. So that's my first thing. I pick a number that is divisible by that number and that one. Okay, so that is my first thing. And then the second thing is I need to pick a number so that when I have something left over here, I don't have, for example, 1 over 20, which I can't plot very accurately with on my graph. So that's why I picked 5,000. You could pick 10,000, you could put 1 million, but make sure that when you have divided on the other side, what you have left to plot is easy to do on your graph. Okay, so here, when x is 0, this means that y is equal to, excuse me, when x is 0, this means that y is equal to 200. So this is the point 0, 200. That is a point on the line. So I put 0 here. Then I have 25y is equals to 5,000. Then you can always check on your calculator. You would say 25y is equal to 5,000. So it means that y is equal to 5,000 divided by 25. And if you see on the calculator, I hope you can see that. There it is. It is equal to 200. So that's where I got it from. And then I do the same thing. Y is equal to 0. This means that x is equal to 250. Okay, so I make y 0 here. So I have 20x is equal to 5,000. And I divide by 20 on both sides. So here I have 5,000 divided by 20. And there I have 250. Okay, so this second point is 250, 0. And again, just to reiterate, this 200 fits nicely on my graph because I was counting y in 200s, and this one I can easily plot it on my graph. So that's why picking this 5,000 was a good fit for me. Okay, if I'd gotten something like 20 over here, I could plot it with a little bit of accuracy, but not very much. So that's why it's important to pick a number here that will fit into your graph nicely. Okay, now the final part is we need to draw our objective function line. Okay, now if you remember what we just did previously, we calculated the x and the y-intercept. We said the y-intercept was at 0, the y-intercept, was at 0, 200, and the x-intercept was at 250, 0. So now all we need to do is just plot them, connect it with a line. Okay, so that's the thing. And I will want to see this when I'm marking. Okay, so 0, 200, this is the point over here. And then what else do I have? I have 250, 0, so this is 100, 200, 250, 0 is there. Then you take your ruler and then you connect them. So this objective function line is usually dotted, or it's a broken line like that. I hope you can see that. Okay, and then I'm going to write down the equation just so that I know which p-value I picked. So over here, okay, so I'll write it at the top over here. This is 20x plus 25y is equal to 5,000. So it's very important to label all of your lines. Okay, so this is my objective function line. Now, why did I draw this one? Okay, now what I do is I take my ruler and I am going to move it like that. And what you will notice is if I drew a family of parallel lines that are parallel to this one of them will pass through my maximum, or what I want to maximize. And if I do that, like that, you will see that it passes through that one. And I can confidently say that this point over here, 675,50, gives me my maximum value. Okay, so this is just using the objective. It's one of the ways to do it. Before I said you could check what all of these values give you, and this line just confirms it. Okay, because it is the profit line, the objective function line, and it does pass through this, or a line parallel to it does pass through it. Okay, so quickly we can just check and see what we will get from the other points, or what profit we will get from these ones. If I make no shirts and 500 skirts, if I make nothing, obviously I will make nothing. I make no skirts, no shirts, I will make no profit. And here 700, 0, 6, 75,50. Okay, so we can do this over here. So I'll write this as, okay, so I have my shirts and then skirts, and then I will just do the profit. I hope you can see this clearly. Okay, so just like that. Okay, so I will compare all of these vertices, or these corner points, and then see that or check rather, that this is actually my maximum point. Now if I make 0 skirts, 0 shirts, my profit is obviously 0. Now you need to remember the formula is 20x plus 25y. Okay, then I move on to this corner here. I make 0 shirts, 500 skirts. Now the profit, if you just need to remember the formula, it is 0 times 20. I don't need to type that in because I know that will be 0. And then I say 500 times 25. Okay, you can see what I have over there, 12,500. So it's 12,500. And then I move on to this one over here. I have 700,0. So this is 700,0. So this one here is just 700 times 20. My profit is 14,000. See, it's bigger than the previous one. And then finally I have 675, and then I have 50. Okay, this I try on my calculator. Let's see what I get. 675 times 20 plus 50 times 25. You can see I have 14,750, which is bigger than all the others. So this is 14,750. So this is how I can maximize my profit, and it is indeed a vertex point. And you can pick any other point. You will see that this 14,750 is indeed the maximum value that you can possibly get. Okay, and then this line over here, we don't use it per se, but it does confirm our findings that this line, if I drew enough parallel lines to it, remember parallel lines never meet, so I draw parallel lines to it, parallel lines, parallel, the parallel line will pass through that point over there, and that point is what gives me the maximum. Okay, so I think that's it. Mike can happily tell his boss that in order for them to maximize their profits, keeping in mind the limitations that they have and the manufacturing process, they need to manufacture 675 shirts and 50 skirts.